we're looking at how to use the unit circle to find each trig ratio in simplest radical form. They might say as an exact value. They don't have to say simplest radical form. Exact means I want the radical or simplified answer, not a decimal approximation. Well, here they're saying sine of 120 degrees. So I look at my unit circle. 120 degrees, right here. What's the value of sine? Square root of 3 over 2. Did I have to draw the 120 degree angle first and solve the triangle? No. Didn't have to find the reference angle. Everything's built into the unit circle. Still an important skill that we did. So if you're asked to do that, you'll need to be able to do that still. But if we're going to use the unit circle, or we've just generated it, and it doesn't say to draw and solve by reference angle, then use your unit circle to quickly attain your answer. Negative 45. Start at 0, 0, go down 45 degrees. That's equivalent to 315. The cosine of 315 degrees, or negative 45, is square root of 2 over 2. The tangent of 225. So I come back to my unit circle. I look at the 225 degree angle, remembering that tangent is y divided by x. So negative square root of 2 divided by negative square root of 2, I get positive 1. And in that quadrant, all students take calc. Third quadrant, tangent is the only one that's positive. Is secant on our unit circle? Is secant on our unit circle? No. But its reciprocal is, what's its reciprocal? Cosine. So if I take the cosine of 300 degrees and then flip it, then I'll have my answer for secant. Cosine of 300 degrees, looking at the unit circle, is 1/2, because it's the x coordinate. Cosine is 1/2, so I have to flip that. That gives me secant to be 2 over 1. Or just 2. Try this for E, F, G, and H. So we're looking at letter A, not letter A, letter E. Cosine of 180 degrees. So we look at our unit circle. At 180 degrees, cosine is the x coordinate. That is negative 1. Sine of 360. 360 is the same as 0. Sine is the y coordinate, so that's 0. Tangent of negative 150. If you can add 360 to it if you want, or you can say if I went positive, it would end here. So in the opposite direction, it ends right here at 210 degrees. That's the same as the tangent of 210. Well, tangent y over x. So this would be negative 1/2 divided by negative 3 over 2, or times negative 2 over 3. What's negative 10 negative? Positive. The 2 cancel. I've got 1 over the square root of 3, which simplifies to square root of 3 over 3 when you rationalize the denominator. Cosecant of negative 120. Well, here's positive 120. I'd go this way. So now if I go this way, it's at the same as cosecant of 240. But I don't know cosecant. I do know sine of 240. Sine of 240 is negative 3 over 2. Well, I don't want sine. I want cosecant. So I have to flip it. So I'm going to rationalize that denominator. I've got negative 2 square root of 3 over 3 for my ratio. Questions on any of those? All right, we're looking next. I don't know why I'm scrolling because I have the paper right here. We're looking next, we're talking about what do we do when we're doing inverse trig ratios? What do we use inverse trig ratios for? Finding angles. What do we have to know to do the inverse trig ratio? We have to know the ratio. We have to know the ratio. So you have known is the ratio. Use inverse to find the angle. Well, there's a couple things we have to pay attention to with our unit circle. Try to pull it up. Probably, and this would be the best thing to do, Ben. unit circle. One thing I want you to notice, and that's why I'm opening it in this document so we can actually see it, is the range. Look at your signs right now. Look at sine, and I want you to look and see what is the maximum value for sine and the minimum value for sine. Looking at all the signs on your unit circle, what is the maximum value for sine and the minimum value? So what is the maximum for sine? Yes. Nope. The largest number for sine is 1. Square root of 2 is like 0.8 something. What's the minimum value for sine? 0. Not 0. -1. So sine of any angle. By the way, it doesn't matter. What if I say, you know what? I don't want a sine of 360. I want a sine of 720. Wait a second, 720. So it would be the same as 0 or same as 360, right? So it doesn't matter. It's going to come right back. It's just going to keep. It doesn't matter how many times I spin around. This sine is going to rotate between 1 and -1 forever. Okay. In fact, the graph would look, and we're not into that yet. We will be when at the next level. Starting at 0, sine as I go around. If I increase the degrees, it does this. It oscillates between 1 and -1. There's a lot of engineering applications there, and science applications that you'll look at later. So for now, though, you need to know that sine of an angle oscillates between 1 and -1. What about cosine? Does cosine does the same thing? It's just it starts at 1 and goes to -1, then comes back around to 1. So there's a discussion of that, but I also want to talk about one other thing. We're talking about inverses, right? If you know the ratio, you should be able to match up the angle. We're talking about inverses. If I tell you the sine is -1/2, which angles on our unit circle have a sine ratio of -1/2? Which one? 330 degrees? 330 degrees would be the angle that would match that up. What else? There's one other one. 210. Okay, I got 2 answers, right? Now think back to middle school. Remember, for something to be a function, when you put in an input, how many outputs can you get if you put in one input? One output for it to be a function. So right now we have a problem that if we're doing the inverse trig function, trying to find which angle matches up, we're putting in the ratio and we're getting 2 different answers. So that's not a function. So in order for it to be a function, we have to restrict this. So that's what we're going to put on our paper in a second. Notice that here's the maximum for sine and here's the minimum. And here's 0. So guess what? When I'm doing sine, I'm going to ignore this entire half of the unit circle if I'm doing sine inverse. If I'm doing sine inverse, and you can write this down on your paper, it doesn't have to be on your unit circle, on that other paper, sine inverse of some ratio. The sine inverse is going to be the angle, right? So we do sine inverse, we get an angle. If I'm using the inverse, then that angle has to be less than or equal to 90 degrees. Well, that would be when the ratio is 1, maximum. Down here is 270. But did I allow us to rotate over here at all? How else could I get to 270 without going past 180? A negative angle. I could go -90 degrees. Or right here, I could do -60 or -45 or -30 degrees. So theta has to be between 90 and -90. This is also true for tangent. Tangent is also restricted this way. That tangent inverse, if you're trying to find the angle using sine inverse or tangent inverse, and it's related to your unit circle, you may only use the right half of your unit circle, and it has to range from -90, has to range from -90 to +90 degrees. So make this note for tangent inverse and sine inverse. I'm going to make it on my paper in a second, but I need to erase this ink because I have to show you what it's going to look like for cosine. For cosine inverse of a ratio, not of theta, of a ratio, that's going to give us an angle. Notice here's the maximum for cosine and here's the minimum for cosine. So starting at 0 for cosine inverse, we're allowed to rotate through the top half of the unit circle to only have one output. So cosine inverse of 1/2 would be 30, whereas cosine inverse of, not of 1/2, that's sine. Cosine inverse of 1/2 would be 60. Cosine inverse of -1/2 would be 120 degrees. So for this, the angle has to be less than or equal to 180 and greater than or equal to 0. So that's what you want to have on your paper. That's what you need to have on your paper. So I'm going to write that down. I want you to see it on the unit circle. We're going to write that down on our paper right now. That when we do sine inverse of a ratio or tangent inverse of a ratio, in order to get the angle has to be less than or equal to 90, greater than or equal to -90, using our unit circle. When we do cosine inverse of a ratio to get our angle, it has to be less than or equal to 180 degrees, greater than or equal to 0 degrees. So that's what you want to have written down on your paper. So now we're going to be asked to find sine inverse of 1/2. So I pull up my unit circle and I say, looking only at the right half of the unit circle, looking only at the right half of the unit circle, ignoring the left half. When is sine 1/2? For which angle is sine 1/2? 30 degrees. There's 1/2, there's 30. So my answer for this is 30 degrees. When is tangent inverse -1? Tangent inverse, again, I only want the right half of the unit circle. Well, where's tangent negative in quadrant 1 or quadrant 2? I mean quadrant 4, quadrant 1 or 4? 4. Where is it going to be -1? Not 270. Tangent. Tangent is y divided by x. Right here at 315, but can I write it as 315? How many degrees back is that? -45 degrees. Cosine inverse, we're finding the angle of when the ratio is positive parts of 3/2. Well, if I'm doing cosine inverse, I'm now ignoring the bottom half of the unit circle and focus only on the top half. So 30 degrees is where it's 3/2. Cosecant of -2. Cosecant, the reciprocal of which function? So I'm actually looking for sine inverse of 1 over -2, which if I rationalize that is sine inverse of -2 over 2. When I'm doing sine, do I want quadrants 1 and 2 or quadrants 1 and 4? 1 and 4. So changing this so I only see quadrants 1 and 4, which one has that answer? Where is -2 over 2? Where is sine -45? 315, which going in the opposite direction is -45 degrees. Try this for letters E, F, and I. E, F, and I. See if you can find where those are. All right, so the conclusions for those. Cosine inverse of -1/2. So I'm looking on the top two quadrants. When is cosine -1/2? Cosine is -1/2 right here at 120 degrees. Secant. The secant inverse, when is secant 1? Well, that's not on the unit circle, but its reciprocal is. Well, 1 is 1 over 1. Its reciprocal is just 1. So 1 is cosine 1. Looking back at the unit circle, cosine is 1 at 0 degrees. So that's what we put down, 0 degrees. And then lastly, cotangent. If cotangent is this, that means its reciprocal function is 1 over the square root of 3. So we need to rationalize that denominator. That would be that its reciprocal function is square root of 3 over 3. And most of you have this on your unit circle from when we filled it out earlier. on your unit circle, that is right here. 1/2 divided by square root of 3 over 2 at 30 degrees, because 1/2 divided by square root of 3 over 2 would be times 2 over square root of 3, which gives us again the 1 over square root of 3, which we could rationalize. So that's the 30-degree angle right there. That concludes the examples that we gave in class today for day 4. Looking at how to quickly generate the unit circle, you have some extra graph paper to practice that. Looking at how to use it to quickly find trig values for special angles that come from the unit circle without having to draw the triangle and find the reference angle and go through all the steps. And how to use the inverse trig ratios with restricted ranges and domains. So we're only looking at the right half, quadrants 1 and 4, for tangent inverse and sine inverse, and quadrants 1 and 2 for cosine inverse when we're finding the angle given the trig ratio. Have a good day.